Today we're going to look at a BK Connect project that will show how you can use the acoustic camera in a noise mitigation project. The project is open. You find your data in the project browser. You see we have a number of different runs here. To look at the map, you just drag and drop the event into the display area. So this is just a speaker sitting on the floor broadcasting random noise. Another thing that is kind of useful on this display is if we start at a higher frequency and drop the frequency lower and lower, so what we're looking at is this frequency band. That's what's getting mapped in the display. And as I go down and down, you can see the spot size gets larger and larger. The source doesn't change. The displayed spot changes because the spot size is proportional to the wavelength of the frequency that you're mapping. And at some point, it just kind of says it's coming from somewhere out there. But when we look at the whole frequency range, because there's not that much energy in the lower frequency, it's a small speaker, but a fair bit here in the mid-range, it gives you a pretty nice spot. Another look at as we go along here is this overall level. So this is the sound power level of this mapped area. And we could change the size of that and just look at what's coming from this area, much lower, or move it right on top, or fill up the whole window. And we'll just fill up the whole window now. You can see it's about 70 dB, just under 70 dB. And the way it calculates that is it assumes that all the sources are omnidirectional point sources just behind the calculation plane. We told it how far away it is. Then it does a pressure to power conversion. So it doesn't comply with any spec or any standard, but it gives us a good indication, are we going in the right direction? So if this was our source and we wanted to put some sort of enclosure on it, drop an enclosure here. Oh, so that did quite a lot. We went from 70 down to 55. So now you can see it's not where the source was anymore. It's down around the bottom that the sound is coming out. So if you built some kind of enclosure that maybe had to have a door and some vent fans, it would be nice to know where around the door is the leak. This will tell you. So maybe we put a seal on it. Just tape it up. Ooh, 55 down to 49. Good. And now you can see it's radiating off the shell. So maybe, what if we put some absorber on the inside? Take the tape off, put the absorber on, and level drops down, and it's coming out the side again. This spot up here is gone, but well, okay, let's put the tape back on just for a fair comparison. Door seal on. Okay, so now there's a little bit down here. Oh, dropped to 43. Good, right direction. It's back on the shell. So that must mean that we stopped what was bouncing around inside with the absorber, but it's still coupling with the shell with the bucket and radiating out. So maybe we need to put a damper. Leave the absorber in, we'll put a damper on and leave our seals in. 38 dB. So we went from 70 down to 38. If you worked with noise, you know that's a huge reduction. And we were able to focus it just on the right areas, right where the sound was coming out, to do the best job.